Welcome, everybody. Hope everybody's staying safe and heeding the precautions to stay home. Let's try to get everybody through this, okay? I'm going to start right where we left off the last time and do another hypothesis testing procedure. And I'm going to use I guess, what you might call a business example this time. One of the things that I really love about this course, love a lot of things about it, but I really want to impress upon students how versatile this course is. People who are scientists, of course, know how to do this stuff, but business people use it as well, for sure. Education, healthcare, scientists, business. This is a really generalizable skill that you can use in a lot of different fields. So let's do a little bit of a business example. And let's suppose that I ran a small restaurant, a small seafood restaurant. And one day, somebody comes in the door, a salesperson comes in the door, and they say, hey, I've something that you might be interested in. I have made a CD that is recordings of sounds that you would hear at the ocean side, so like waves and seagulls are like ee, ee, ee. No, I can't do a seagull very well, and maybe some distant horns from a lighthouse or something like that. Anyway, this salesperson. Oh, by the way, he's going to call this the CD. Get it? CD. Anyway, the salesperson's claim is that if I play this CD in my restaurant, that it's going to create an ambiance that will kind of encourage people to spend more money in my restaurant and buy more seafood because they really like the ambiance. And so he wants to sell it to me for $250. And as a good business person, I'm going to say, are you crazy? Get the hell out of here. No, that wouldn't really be a good business person. I would want to try to, assess whether or not it's worth $250. I wouldn't say no automatically. I, of course, wouldn't say yes automatically either. What would I base my decision on? That is, my decision to buy that CD, what would I base that on? Well, hopefully you're thinking to yourself, well, is there any evidence that it works? Is there any evidence that it works? And that's exactly what I would want to see. I would want to see some data. I want to see some evidence that it works. And so, so let's do that. Can we collect some data so that we can make our decision about whether or not to buy this CD? Okay? Well, so I'm going to tell the salesperson, listen, will you let me use the CD for 1 week, and then I'll make my decision based on whether or not it increases sales. Everybody with me? I'm hoping that this sounds quite logical to you, okay? So let's do this. Let's suppose that we know, so this is given data, okay? So let's suppose that we know that normally we take in about $975 a night at my seafood restaurant, okay? Normally we take in $975 a night. Of course, from night to night there is variability, and so suppose that the standard deviation then is $100, okay? Now, what I want to do is I want to assess whether or not the CD works, and so I'm going to compare it to what we see normally without the CD, okay? Let's go through our 5-step procedure. Let's go through our 5-step procedure and see if we can't make an assessment about whether this CD works, okay? Step number one, as you recall, step number one is to set up our hypotheses, okay? So we're going to talk about the null hypothesis. Let's leave a little space here too, and we'll talk about the alternative hypothesis or the experimental hypothesis. I'm going to start here, okay? I'm going to start here. I'm going to say, okay, so what I want to test, the hypothesis that I'm curious about is whether or not playing the CD, so this is the CD, right? Whether or not the average will be different than what we see normally. I mean, that's the question, right? The CD, is it going to be different than what we see normally? Since I know what normally means in this case, then I can also write it like this. Is the CD going to make a nightly sales different than $975? Okay? So that's what we're going in to ask the question. I'm going to make that a question about the null hypothesis. This is like what we talked about before, right? I can never prove this. So I'm going to set up the null, and this is how the null will look, and that is when I play the CD, I'm not going to see any difference than what I would see normally with my sales. Since we already know that, I can rewrite that null hypothesis like so. Okay? This would mean that the CD didn't cause any change, didn't have any effect on sales. This is saying that it will affect sales, that our sales are going to be something different than 975. Once again, this is called a non-directional hypothesis. I'm not saying that the CD is going to increase sales. I'm not saying a CD is going to decrease sales. Okay, I'm just going to say it's not going to be the same as what I normally see. Okay, not making any directional guesses. So this is called a non-directional hypothesis. It's also called a bidirectional hypothesis. That is, I'm going to be able to say something whether it's higher than 975 or lower than 975. Okay. Also, sometimes people will ask me in class, well, should we put the alternative hypothesis this way or this way, right? Or should I write the null this way or this way? Well, some people prefer this, some people prefer this. I'm always going to show you both when I do the example. And if I were a student taking the exam, I want that professor to know that I really know my stuff. And so I would do it just like I'm writing it. I mean, there's no real reason to choose one or the other. Some people teach it one way or the other. That's fine. I like to show both, okay? So that's step one. Step two, let's put step two right here, okay? And step two is defining our decision criteria. And the way we're going to do that, we call it setting our alpha level. So in this case, we're going to say alpha level equal to 0.05. That corresponds to a z of plus or minus 1.96. Now I'll draw the curve here, but we're going to need to get away from drawing the curve. When you see these two things, you should sort of understand that that represents a curve that looks like this. Here's our z of 1.96, right? And what we're saying is if our data fall in these extremes, we're going to make a decision that whatever treatment we imposed has cause and effect. Okay? So our alpha level, 0.05. That's not subtraction error, that's just our alpha level. A z-score of minus 1.96 or plus 1.96. Okay? If our data fall in here, I'm like, okay, it doesn't look any different from normal. If the data fall here or here, I'm going to say, boy, that doesn't look normal to me. Okay? We've covered this before. Step 3. Let's collect our data. Okay? In this case, we're going to look at 7 nights. So our sample size here is 7. Okay? And let's play the CD. Let's keep track of our sales. And let's suppose that we had data that looked like this. First night, $987. Second night, $1,001. Third night, $1,109. Fourth night, $1,023. And then $1,221. And then $1,174. And then $971. Okay? So those numbers, 987, 1001, 1109, 1023, 1221, 1174, 971. So we're going to get the mean for this sample, right? This is the mean for the CD sample. And what is that mean? I think if my calculations are right, 1069.43. $1,069.43 is our average for 7 nights. Okay? Now, we're going to do our statistic. Okay? This is sort of step 3 continued. Did I label this as step 3? Yep. Okay? So our mean for the CD group is 1069.43. Okay? And this is mean for 7 nights. Okay? Now let's think about the statistic. Okay? I don't want you to just sort of like, I'm going to tell you what this is, and you're just going to write it down, and you're not thinking about it. What are we really doing? I want to compare this to what we see normally, right? So we're going to compare our CD mean to, oops, that's subtraction. We're going to compare to what we would see normally, that is without the CD. We're going to divide by the variability that we see normally. So my CD mean, I'm going to compare it to what I would see normally divided by the variability of what we would see normally. So this is going to be our z-score, right? So Z is, I'm going to compare 1069.43 to what we would see normally with groups of 7, that is 7 nights. What would be our normal average? Well, we know that. That was given. Okay. Here's the key. This is the key. Okay. We had 100 as our standard deviation, but remember, we're looking at groups of 7 nights. So we need to do that. Central limit theorem, right? This is equal to our standard deviation for individual scores divided by our sample size. Okay? When we do this calculation, 1069.43 compared to 975 divided by 100 divided by the square root of 7, this is something like 37, okay, 37.7 something. We have a value for our z-score of 2.50. Okay? That's our z-score for the CD. Now let's go back over here, okay? Step 2. What we're saying is, here's our CD sample out there. Now, that doesn't look like what we would normally see, that is, without the CD. And somebody's like, yeah, but we played the CD. But if the CD did not have any effect, we would expect that group of 7 nights to be in here somewhere, okay? But it's out here. And so that's how we're going to make our decision, right? This is step 3, collect the data, do our statistic, okay? Step 4, we have to make our decision about the null hypothesis. Step 4 is always making a decision about the null, okay? So let's go over here. Just remind ourselves of the null. Does it look like the CD belongs to a population that has a mean of 975? Does it look like the CD belongs to a distribution that has a mean of 975? This is what it would look like, right? Our answer is no. I mean, we're so far out that it doesn't look like this is the case. Okay? So we are going to reject the null. Okay? Now, I want people to, if you think this through, you don't have to memorize stuff. Is memorizing, I don't know what the attraction is to memorization, but what we're saying here is the 7 nights where people were listening to the CD is out here. It doesn't look like normal groups of 7 nights. This doesn't look like it's the case, okay? We're going to reject the null. Step 5. It appears that playing the CD significantly increases sales. Make sure you say increases or decreases or whatever your data tell you. This is higher than 975, right? So it appears that playing the CD significantly increases sales. I don't want this to be based on my opinion. My opinion doesn't matter. Your opinion doesn't matter, okay? You can have opinions, but I want to make my decisions, my business decisions, my medical decisions, my research decisions, my decisions about education. I want them to be educated decisions, and we have data. I'm making this statement based on what we found, okay? So I'm going to justify this. I'm going to say, hey, I'm saying this because I have a z-score of 2.50. And please, folks, we're going to report our data. The criteria that we used to make the decision, that z of 1.96, that was our criteria. But right now we're making the decision, we're making a statement based on the fact that we got a z-score of 2.50. I'm going to put a semicolon here, okay? P less than 0.05 appears that playing the CD significantly increases sales. Here's the justification. Let me talk about this again. Okay? This is P less than 0.05. The short version of that, which is easier to remember but not as good of an explanation. This is the probability that the null is true. This is the probability that the null hypothesis is true. If the probability of the null hypothesis is less than 5%, well, then I'm going to reject it. That's pretty low. Okay. Let me give you I think, a better explanation of that number. This is saying that the probability that we would get a mean of 7 nights, the probability that we would get a mean of 7 nights of 169 normally happens less than 5% of the time. Let's go back here. We expect, if the CD did not work, we would expect about 975. What we found is out here. The probability that we would get something this far out, man, the probability we get something that far out, given this population, occurs less than 5% of the time. And so we reject the null. We reject this. This is our alternative. That's why it's called the alternative. We reject this, so we use this as our alternative. We say, I don't think the average population of CD evenings, that's hypothetical, all we've seen is 7, okay? All we've seen is 7 nights. But we're going to go back to this, and I'm going to say, I think that the population of CD evenings, I think the mean is different than 975. Okay, reject the null, go to here. Here's our statement, okay? Of course, when we say that the CD population is not 975, I'm going to follow that up because this is kind of an interesting question, right? Let's go back here. We rejected this, so that's we go to the alternative. Well, I don't want to know what the CD population, what the mean is not. I'm going to ask you to guess, what do you think it is? What do you think the mean is for the CD population? We're saying it's not 975, but what do you think it is? Well, we're going to have to go back, I don't know, 2 or 3 or 4 videos ago and say, when I put my hand in that canvas bag and pulled out a sample, my guess for the mean for that canvas bag was the mean of that sample. I'll say it again. When I pull something out of that bag, I'm expecting it to be close to the mean. In fact, that would be my best guess for what's in there. And so here's our conclusion. My guess for what's in the bag, I'm going to go right back over here. I'm going to say, I know we only saw 7 nights, but this is going to be my guess, my best guess for the population mean for the hypothetical population of people listening to the CD, okay? The sales that we'd see at night. All right? By the way, my average is almost $94 per night. $94 per night more with the CD. If this salesperson wants $250 for it, I'm writing a check. I'm writing 2 checks. Give me 2. Okay? I'm ignoring the fact that I could make this CD by myself. But if someone says $250, I'm like, absolutely, man. I'm going to make that up in 1 week. If this is the difference in nightly sales, I'm going to make that $250 up quickly. Okay? So I would buy the CD not because somebody told me, not because I think it's going to work, but because I have evidence now. I have evidence now that the CD actually works. Okay? So, let's do another example. 5 steps, start to finish. Let's see if you can do it. I'll go through and work the steps, but let's see if you can do this. Maybe I don't know. Let's see how it goes. Okay, let's go back to another psych example. Next week I'll do a PT example. I'll do a neuroscience example. I try to use lots of examples. So we did psych and business, and let's do another psych example. Maybe I'm interested in the effects of caffeine on simple cognitive tasks. Okay, and so I had a student who did a project like this several years ago. Because it's kind of it's a cool idea, I suppose. So let's think about a simple cognitive task. Let's do a word search, okay? Let's do a word search task. And we'll make it fairly simple. So we'll set up this word search, and let's say that normally people can do this in 60 seconds, this word search, okay? Of course, folks, of course there's variability. This is old news, right? Not everybody's going to do it at 60 seconds. Let's say that the variability is 15 seconds, okay? So some people do it quickly, some people do it not so quickly, but on average, let's say that the average is 60 seconds, okay? What we're going to do then is we're going to give people 100 milligrams of caffeine, and so this is what we normally see people do. Okay, this is normally they do it here. Let's give 100 milligrams of caffeine and see if it affects their completion time. Okay. So, step number 1, can you give me the null hypothesis and the alternative hypothesis? Okay. So write those down. Let's see if they match what I'm going to write. Everybody got it? Are we ready? So the null would say that when I give caffeine, we're going to see the same completion time as what I normally see. Okay? When I give caffeine, we're likely to see completion time around 60 seconds. That's the null. That's saying that the caffeine won't have any effect, right? The alternative would be that when I give caffeine, I'm going to see something completion time different than what I normally see. Again, I'm going to use a non-directional hypothesis here, okay? Because maybe caffeine will make it harder for people to complete it. Maybe it'll make it easier. I don't know. I just want to test whether there's a difference. And again, this would mean that the caffeine group would have a different completion time than 60 seconds. Okay? I bet you guys did that. Right? It's just a matter of getting used to writing this down. So, good job. So that's step 1. Okay? Step 2, I'm going to say my alpha level is equal to 0.05. that corresponds to a z-score of plus or minus 1.96. Okay? Did you guys get that? I'll do it one more time. Here. What we're saying is, here's our criteria. This is my z of 1.96, right, minus. This is my z of 1.96 plus. If the caffeine group is in here, I'm going to just say, well, they look normal, right? If the caffeine group is in here, they look just like people not getting caffeine, okay? If the caffeine group is down here or up here, then I'm going to say, wow, they don't look like the non-caffeine group. They don't look normal, okay? That's where that's coming from. I really feel confident you guys got that too. Okay, let's collect the data. Let's get 8 people. We're going to have them complete the task, and let's look at their times, okay? Let's look at their times. 45 seconds for the first person. 46 seconds for the second person. 51 seconds for the third. 64. 40. 56. 43. And 70. Okay? 45, 46, 51, 64, 40, 56, 43, 70. So that's our group of 8 people. Okay? And the mean for these 8 people, if my math is correct, the mean is, I'm running out of room anyway. The mean is, this is for the caffeine group, 51.875. Okay? Now, some people ask me, well, do you want us to do 2 decimal places or 3? Well, I mean, whenever you round, you're kind of making a mistake. I always want you to go to at least 2 decimal places. One of the things that's interesting about whole numbers, if it's a group of 8 whole numbers, will always give you an answer which is 3 decimal places, and then the rest are zeros. Okay, so it's 0.875 or 0.125 or 0.250 or 0.500. Okay, that's just a fun fact about numbers. I'm going to retain the 3 decimal places just for that reason. I'm assuming you can get the mean for this group. Okay. Now what we have to do is, and this is kind of a continuation of step 3, and here's the logic, okay? I want to compare my caffeine group. I want to compare, that's what the subtraction is, to what I see normally, but for groups of 8, okay? That's why it's mu sub m. I have a group of 8. I want to compare it to groups of 8. And then the standard error for groups of 8, okay, the standard deviation for that distribution, this gives us our z value, okay? This gives us our z value. And so we look at, what was it, 51.875 compared to 60. And this is 15 divided by the square root of 8. Okay? We're going to use our central limit theorem. So it's this, the standard error is equal to the original standard deviation divided by the square root of the sample size. In this case, we have 8 people. I want to compare a caffeine group to what groups of 8 would look like non-caffeinated. Standard deviation for the non-caffeinated groups of 8. Caffeine, group of 8, compared to what all groups of 8 who are non-caffeinated, and the standard deviation for all the non-caffeinated groups of 8. Okay, I mean this course is so cumulative that you have to have those other videos to make this make sense. So our z here, if my calculations are correct, is going to be a negative z-score, right? This is below 60, so this is going to be negative, and it's 1.53. Okay. Okay. Step four, we need to make the decision about the null hypothesis. Okay, let's go back. Here's the null. Okay, it's saying that caffeine will have, the population will have a mean of 60. The mean of 60 is here, right? If my caffeine group is in here or in here, then I'm going to say, wow, that doesn't look like 60. Okay? Here is my caffeine group. Z-score of 1.53 minus, that is below the mean. I can handle that. You guys can handle that. Let's go back over here. Okay. So here's where my caffeine group is. That is, it doesn't fall in the extremes. So I'm going to reject the null, or am I going to fail to reject the null? Am I going to reject the null based on this? Or am I going to fail to reject the null? Well, this caffeine group looks like it's a non-caffeine group. And so, in this case, sorry about that, in this case I'm going to fail to reject the null. Fail to reject the null. Okay? I'm not rejecting the null. I'm not going to my alternative. Oh, this is interesting. The reason I wanted to do this example is because we're going to come up with now a different conclusion, of course. And so step 5 is our conclusion. And I'm going to say it appears that 100 milligrams of caffeine does not affect completion time. And I'm basing this on the fact that this wasn't extreme enough for us to reject the null. This wasn't extreme enough for us to reject the null. So we failed to reject. I'm saying that this group looks like people that didn't have caffeine. Okay. Now I'm going to, for sure, report my statistical analysis. Remember, folks, don't put 1.96 here unless that's what you calculated, but the 1.96 is our cutoff. This is our actual data number, okay? And then in parentheses, after semicolon, P greater than 0.05. The P is greater than 0.05, okay? Let me go over what that means again. So this is the probability, the short version, this is the probability of the null hypothesis being true. Okay? It's greater than 5% that is true. That's why I didn't reject it. But don't try to memorize this, okay? Fail to reject. I'm saying that the probability that the null is true is greater than 5%. I'm getting that from here, okay? It fell in this sort of common or typical region. Our caffeine group looks like it's from the non-caffeine group, okay, from the non-caffeine population. The group that got caffeine looks like it's normal, okay? Failed to reject. It appears that 100 milligrams of caffeine does not affect completion time. Here's my stat. Here's my probability statement, okay? 1 through 5, that's how it works. Now, I've included a little bit more detail in this conclusion, and there's a reason for that. It may be that if I did this experiment with 200 milligrams, it may be that it would cause a significant decrease, okay? And this is one of the things with science that a lot of people don't understand, and I want you guys to be sophisticated enough, right? You're paying the big bucks for tuition. Hopefully you're getting something out of this. Sometimes people will read in a magazine, they'll say, well, this group of scientists said that caffeine has this effect, and this other group of scientists said that it didn't have an effect, and they don't know what they're talking about, blah, blah, blah. And I'm like, wait, whoa, wait a minute, okay? If this research was done using 100 milligrams of caffeine, they might come to the conclusion that it doesn't have an effect on completion time. If we did this experiment with 200 milligrams, we might see that it actually improves people's performance, that is, will lower the completion time. In that case, one headline would say that caffeine doesn't have an effect. The other headline would say it does have an effect. As they say, folks, the devil's in the details a little bit, okay? So I'm including here 100 milligrams especially because it's starting to look like, there might be a little bit of a decrease. It wasn't a statistically significant effect. So I'm going to say it doesn't affect completion time. But I might follow this experiment up with an experiment that where we give 200 milligrams and let's see what happens. Let's see what happens. It could be that if we do 200 milligrams, we're not going to have a significant effect. It could be that we would. The point here is that you have to pay attention to the details because sometimes they matter a lot, okay? So hopefully these two examples, one where we found a significant effect of the CD, one where we didn't find an effect, and of course if we go back to the taste experiment, we found that the red food coloring had an effect. Interestingly, that was an effect that was in the opposite direction of what we had anticipated. So there's 3 examples. There's more examples in the book. And for the next video, we'll actually go back to some more conceptual stuff. We're not going to do any computations for the next video. I'm going to show you what happens when we do inferential statistics. Remember, when we do inferential statistics, what does an inference mean? It means a guess. And when you do inference, when you make a guess, what are the 2 possibilities? You can be right or you can be wrong. Okay? You can be right or you can be wrong. That's why I always do it appears that, it appears that, it appears that, because all of this is based on probabilities. We could be wrong, but it's a good system to assure that you minimize the chances of being wrong. So that's what we're going to talk about in the next video. And until then, be safe, take care of yourself, and I'll see you the next time.